guys, this is Miss Morrison. We're on 3.1, which is about linear measure, and that's just a fancy word for converting. Yeah. And we're converting between the metric system, which is like what everybody else in the world uses, and the English system, which is what we use in the United States. But if you go over to like Great Britain, they use the metric system. That's why all of our shoes, they might say 11 for 11 inches, but then they also say 43 for 43 centimeters or something like that. For people who want to buy the shoes who know the metric system. Alright, so first let's look at this top right problem. It's kind of a random problem from, I think, 2 sections ago. It says, can the following be the lengths of the sides of a triangle? Well, let's remember that if you add up 2 sides of the triangle, it should always be bigger than the third. So, let's try adding up these 2 sides of the triangle, 15 and 10, and that makes 25. And is that bigger than 24? Yep. So 2 of our sides, when we added them up, it's bigger than our third side. Let's try 2 different sides. Let's try 10 and 24. 10 plus 24 is 34. And is that bigger than that third side? What was the third side? 10, 24, 15? Yeah, it is. Okay. Well, let's check one more set of numbers. Let's try the 15 and the 24. 15 plus 24, that makes 39. And it's supposed to be bigger than the third side, which is a 10. And it is. So since all 3 of these work out, that means, yes, we can have a triangle this size. If when I added 2 of the sides, I did not get something bigger than the third side, I would say no, it's not a triangle. Alright, let's look at this conversion. Before we talk about the conversion, let's just talk about size of things. Okay, if we're on a ruler, here's a picture of a ruler, okay? On one side, there's inches. Like down here, it's inches. Yeah. Up here is centimeters. This 1 represents 1 centimeter. This 3 represents 3 centimeters. But the millimeters are these little tick marks, these super tiny tick marks with the centimeters. So like this little bitty tick mark after the 2 would be 10, 20, I think 21 millimeters. So millimeters are super tiny. They're these super tiny lines, the super short ones. Okay, centimeters are the bigger lines. And then inches are on the other side. Okay, so let's look. 1 centimeter is how you would describe a pea that you eat, you know, like green peas. Yeah, that's about as big as a centimeter. A peanut is about the size 2 centimeters. A small strawberry is 3 centimeters. Yeah. A small lime is 5 centimeters. I know I keep talking about small, but these are measurements of the fruits back in the day. Right now, our fruits are freakishly big. Okay. Anyway, so, okay, then let's look below here. That same green pea that was 1 centimeter before is now 10 millimeters. What? That 1 peanut that was 2 centimeters before is now 20 millimeters. That line that you saw before of 5 centimeters is now 50 millimeters. So we can measure things with different units. It doesn't matter. Okay, and the way we get from centimeters to millimeters is it looks like you have to multiply by 10. For my green peas, I see 1 times 10 is 10. Look at your peanut. 2 times 10 is 20. Look at your lime. 5 times 10 is 50. So that's where this times 10 hoopla comes from with this conversion. When we have the English metric system of inches and feet and yards, it's more difficult to convert. But when we're talking about this British metric system, we just multiply or divide by 10. Okay, let's look at these examples. We have to figure out which word, which measurement would fit for how big this prompt is talking about. So let's see. This first prompt says choose an appropriate metric unit to measure the distance a touchdown pass traveled. Okay, well, a touchdown pass, that's like across a football field. Okay, football fields are way bigger than this little green pea of a centimeter. That's like a bagillion green peas, okay? So we're not going to say centimeter because a football field is too big. We're not going to say millimeter either because, golly, that's even smaller. That's one little tick mark on a ruler. Okay, we are either going to say meters or kilometers. Okay, kilometers is huge. Kilometers is kind of like a mile. It's that big. Meters is kind of like yards. Yeah. Okay. Kind of like a yard. Anyway, so how do we measure football fields? Do we say it's 4 kilometers long, 2 kilometers long, or do we talk about it in meters? Well, let's remember the football field has like a 50-yard line. Yeah. So we talk about football fields in meters, or you could try kilometers. But I would probably say meters. Kilometers is a little bit too big. Okay, let's look at the next sucker. It says choose an appropriate measure of a height of a semi-trailer. Okay, are we going to measure the height of a semi-trailer with a bunch of green peas? No, that would be a ton of these little peas. So centimeters and millimeters, again, is too small for this. So we could either talk about meters or maybe even kilometers if it's a decimal. I would probably say meters though. But centimeters and millimeters are way too small. Okay, the last sucker says choose an appropriate metric unit to measure the span of a hand. That's like how long your hand is. Okay? How should we measure our hand? With a bunch of little green peas? Because that would be like, I don't know, 20 green peas? Or should we measure our hand with these little bitty tick marks? Yeah, it's more feasible to measure our hand with centimeters, the size of those peas, because millimeters is way too small. So millimeters is way too small. Kilometers and meters are way too big, so we're going to use centimeters. Okay, and then if the homework asks you about pencils or something, the lead of a pencil, here is a millimeter. The head of a crayon, millimeters. The eraser of a pencil, millimeters. Okay. So big things are measured in kilometers and meters. biggest things are measured in kilometers. Okay, now we're going to do some converting. So we haven't actually done anything with numbers. Okay, part A says millimeters to centimeters. Okay, well, let's go back up to this chart and look for millimeters. Here it is. Okay, now look for centimeters. There it is. So we just have to go 1 dividing by 10. We just have to divide by 10. So we're going from millimeters to centimeters. So we're going to say 40 and then divide by 10. 4. So 40 millimeters is 4 centimeters. And that makes sense because we already talked about this. 1 green pea is just 1 centimeter. But that's 10 millimeters. So that's totally right. Okay. Let's look at this nutsucker. 391 m to blank km. That means meters to kilometers. Okay, let's find where we're at. Meters. Hey. Kilometers. Hey. So we have to go from meters to kilometers. Whoa. 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 Oh. So we had to divide by 10. 3 times. Oh my gosh. So we're going to take 291 and divide it by 10. Then divide it by 10 again. Then divide it by 10 again. So we're going to have 291 divided by 10. Divided by 10. Divided by 10. Hey, 0.291. And whenever we take a test on this, you definitely got to write this conversion chart. I think some people know something about it, like King James had a I don't really remember it though. Okay, let's look at part C. It says kilometers to meters. Okay, this is going backwards. Here we're starting on kilometers, but we want to go to meters. So we're going this way. Yeah, okay. So it looks like we have to go once, twice, 3 times to get to meters. And we have to multiply by 10. So for part C, we're going to take that 2 and we're going to multiply by 10. Then again, then again. And that should give you 2,000 meters. So 2 kilometers is 2,000 meters. Okay, let's look at D. 20 millimeters to meters. So let's see. Millimeters to meters. Where's millimeters? Here it is. Here's millimeters. And we need to get to meters. So from millimeters to meters, we're going to divide by 10 once, twice, 3 times. Once, twice, 3 times. Okay. So 20 divided by 10. Then again. Then again. And if you haven't figured it out, dividing by 10 or multiplying by 10 just moves the decimal. So we get 0.02 meters. Wait, did I do that right? Yeah, I did that right. Because I went from millimeters to meters. Woohoo! Okay, so you either multiply by 10 or divide by 10. Alright, now let's look at the English metric system, which is how we operate here in Texas. Yeah, America, yeah. Okay, 1 foot is 12 inches, 1 yard, 36 inches, 1 yard is 3 feet, 1 mile is 5280 feet, 1 mile is 1760 yards. Okay, let's see here. First, we have to figure out which of these 3 words, feet, inches, or mile, is best appropriate. Okay, I think we're going to be a little bit better with this. It says, choose an appropriate English manner. The cruising altitude of an airliner. That means how high the airplane is. So, how high in the air does an airplane get? Does it get a couple of feet high? Does it get a couple of inches high? Does it get a couple of miles high? Okay, when you're talking about the cruising altitude, that's when they're just cruising. Does not mean when the airplane is crooked. Yeah, whatever. It means when the airplane is just going side to side. Okay, so when the airplane is up in the sky and you can barely see it, is it feet above you, inches, or miles above you? It should be miles above you, because that's a long way. Okay, what about the border of a state? Let's say Texas. If we want to know, I forgot how to draw Texas. Oh, well. Okay, well, this is Texas. Okay, and if I want to know the border of it, how am I going to measure the border of Texas in real life? Not feet, not inches, miles. Okay, next thing, length of a couch. Okay, when you go to Nebraska Furniture Mart and you're looking for a couch, they're not described in miles. And they're not described in inches. They're described in feet. Because if I described a couch in inches, the number would be way too big. If I described a couch in miles, the number would be like a decimal or something. Alright, now it says to measure the width of a piece of paper. Width. So, how are we going to measure how wide this piece of paper is? With feet? It might not even be a foot. Inches? Yeah, there's a bunch of inches here. Or miles. Oh, heck no. Miles is for like something huge. So, inches. And those are pretty common sense. If I put those on the test, I'll put something that's easy, like piece of paper and maybe airlines or something, because those are super obvious. Okay, let's look at this top right. It says complete each of the following, and we're just converting. Alright, this one's not as easy as the British metric system, because the British metric system is based on tens, base 10. Ours is not. We have a 12, a 36, a 3, a 5280, a 17. Yeah, darn. Okay, well, let's see here. We're going to try making proportions. I think you will like this. Okay, so let's make up some proportions. For part A, I'm going to put the inches on top and the yards on the bottom. Okay, so we say they gave us 140 inches. Is how many yards? We don't know. But we do know that 1 yard is 36 inches. So I'm going to put the 36 on top, because that's where inches go. Inches. And I'm going to put 1 yard on bottom. Okay? And then we're going to cross multiply and divide. Okay, let's try and remember how to cross multiply and divide. You multiply the diagonal numbers that have numbers in both spots. So 140 times 1. Then you divide by the number in the diagonal with the question mark. So we divide by 36. Okay, and I'm not sure if this comes out pretty. Let's check. 140 divided by 36. Oh, it does not. Okay, so 140 divided by 36. It does not come out pretty. I get like 3.8 something. Yeah. Okay, so we could either say 3. Let me maybe round to a 9. 3.9 yards. Wait, I think I did that wrong. Hold on. No, I did it right. Okay. 3.9 yards, or if your homework does not allow decimals, let's see how we're going to do this. 140 times 1 is 140. Divided by 36 is over 36. Okay, I can reduce this a couple of times. I think I can reduce it maybe by 4. And I think it comes out to be 9 on the bottom and 35 on the top. Okay. Let's try and make this 3.9 yards into like a mixed number. Okay, let's see if we remember how to do this. We say 9 goes into 35, 3 times for sure to make 27. Then we subtract down and you get 8. So this 3.9 yards is the same thing as 3 and 8 over 9 yards. Remember, you put the remainder 8 on the top of the fraction and the number you're dividing by on the bottom of the fraction. So depending on what your homework wants, if they say it's okay for a decimal, put 3.9 or round however they tell you. If they don't, we're going to have to do old school division. All right, let's go to part B. Part B says, okay, well, we started out with yards, and we're going to inches now. Okay, well, we can start with the same proportion, inches over yards. This says 360 yards, so I'm going to put the 360 on the bottom, and it says question mark for the inches. Well, we know a conversion that deals with yards and inches. It's right here. 1 yard, that goes on the bottom, is the same as 36 inches. Hey. Okay. If you know an easier way to do this, you can do it your way. For example, on part A, if you just did 140 divided by 36, if that was your shortcut, that's cool. Or if you did 140 divided by 12 times 3 or something like that. If you did a shortcut, that's absolutely cool. I'm just trying to show you a proportion because you definitely have to teach that. Okay, so let's cross multiply. Pick the diagonal with both the numbers, 36, 360. Then divide by the diagonal with only one number, 1. So we're going to say 360 times 36 divided by 1. And 360 times 36 is 12,960. And then if you divide it by 1, you still get 1290. 12,960. And again, if you used a shortcut on that and you just said 360 times 36, that's cool. You do you. Okay, let's go to part C. Part C says feet. Okay, so that means we're dealing with a new proportion. We're talking about feet and what's with the blank? Yards. Okay, well, they say 390 feet, so I'm going to put that on top. Question mark for the yards. We don't know. Well, let's look at our conversions and see if I have anything that involves feet and yards. Not this first one, not this second one. Oh, hey, look at that. Okay, so we're going to put the 1 and the 3 in this proportion. Where are we going to put the 1? It says 1 yard, so you're going to put that on the bottom because that's where the yards go. On the top, it says 3 feet, so let's put the 3 feet. Okay, then cross multiply the diagonals that have a number in both. So 390 times 1. Then divide by the diagonal that only has one number. So divide by that 3. And that should come out pretty to 1, 3, 0, and what were we looking for? Yards. Okay. Yes. All right. The last sucker is inches to feet. You might not be able to do that on your own without a proportion. You probably can. Okay, let's think about this. How do we get from inches to feet? How many inches are in a foot? 12. Yep. So we could either set up a proportion, or using inches and feet, or we could just say 348 divided by 12. It doesn't matter. Okay, so if I used my proportion, I would say inches and what else is this problem talking about? Feet. So then my little equation of fractions would look like 348 on top, inches, over question mark, feet. Then I would look for inches and feet in this conversion box. Inches, 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 inches. But we need feet. Inches and feet. Where 12 inches is 1 foot. And then if we cross multiply and divide, you can see that we do 348 times 1 divided by 12. Yeah, and that's the same thing as 348 divided by 12. So it doesn't matter if you use the fractions or if you just use your brain. Either way, we get 29. And the question mark was for feet, so feet. Huzzah. Okay. Last bit of this before we move on to circles. Yeah. Okay. It says, guess the perimeter of each of the following figures using the unit scale provided. Okay, and over here on the right, it says perimeter is the distance around the edge of the shape. Okay, well, let's see here. This is 1, so maybe this is 1. Yeah. Maybe this is another 1. And this is 1, and this is 1, and this length 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 is 1. Anyway, so if you add them up, 1, 2, 3, 4, 5, 6, 7, maybe 8-ish units. Yeah, we're kind of rounding. All right, let's look at this guy. Okay, let's say it has 2 on the side. Let's see, this looks like 1 also. This up and down looks like barely 1, but close enough. Okay. And then how many ones across will we have the top? We'll have 1, maybe another 2, maybe another 3. Then along the bottom, how many are we going to have? 1, maybe, and a 2, sure. Okay, and then this piece, we got to figure out this piece. This piece is maybe 1 again, and maybe 1-ish. Okay, so we're kind of rounding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think this is 11 little segments. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. 11-ish. So because it says guess, it's okay that we have that little ish on it. You don't actually type in ish in your homework. All right, let's keep going. The next thing we're going to talk about is circles. The perimeter of a circle is called the circumference. Yeah. So the perimeter of a circle is called the circumference. And the circumference is found by 2 pi r. R is halfway through the circle. It's from the middle to the halfway out. Diameter is 2 radiuses put together. Yeah. Okay, let's look. It says, if a circle has the dimensions given, determine its circumference. Okay, circumference is 2 pi r. So we already know the formula. Okay, for part A says diameter. Well, we need the radius, r. So if the diameter is twice the radius, how do we go backwards? Divide by 2. Yeah, so we're going to divide by 2. And that means for part A, 10 divided by 2 is 5, and that's the radius. All right, now let's throw it in that formula for C equals 2 pi r. The C and the 2 pi stay the same. The r changes to whatever it is, 5. Then, when you multiply them in your homework, just multiply the numbers. 2, 5 makes 10. Then, rewrite the pi. And I think in your homework, you can type the P button, then the I button on your keyboard, and it turns it into like a pretty bold pi. Yeah, so if you can't find the symbol for that pi, just try typing PI, and it should turn it into a pi. Okay, so our circumference is 10 pi, and your homework wants you to keep it that way. Okay, let's look at part B. They already gave us our radius, huzzah! So circumference equals 2 pi r. The C and the 2 pi stay the same. The r changes to a 8 over pi. And then let's see here. What happens to the pi's? Well, one is being divided on the bottom because there's a division bar. One is being multiplied on the top because it's right beside a parentheses. Those are opposites. They cancel. So all we have left are the numbers. 2 times 8, 16. Hey, that's the circumference of a circle with radius 8 over pi. Okay, the next thing that we're going to talk about is arc length. Arc length describes how long the outside of this one section is. It's kind of like the crust of the pizza. Yeah, we're trying to find how long the crust of the pizza is. And the crust of that pizza comes from the circumference of the whole pizza. So that's where this 2 pi r comes from in the formula. Because arc length is just a piece of the whole circle's crust. Okay. So anyway, r represents radius. Theta, or that 0 with the cursive looking thing, that's the angle in degrees. Yeah. Okay, so let's find the arc length. It says let's do what the problem says. Find the radius of the circle containing a 20-degree arc whose length is 16 pi. Okay, so let's see. We got a circle. Its radius, we don't know. The section that I make has 20-degree angle inside. And it says find the radius of the circle containing a 20-degree arc whose length is 16 pi. So this crust of that slice of pizza is 16 pi. Yeah. So the pizza crust is the 16 pi. The 20 is that little angle in the degrees. The r is the r that we're trying to find. Okay, so our formula says arc length equals 2 pi r theta over 360. Okay, well, let's fill in our goodies. What is our arc length? It's the pizza crust. It's 16 pi. On the right, the 2 pi stays there. The r, we don't know. The angle, we do know. It's 20 all over 360. Okay, well first let's multiply. We're trying to get r by itself. We're trying to get r by itself. So right now we have a dividing by 360, and that's weird. If I'm trying to solve for r, you can't have something dividing by it. So let's get rid of this divide 360 using algebra. What's the opposite of divide 360? Multiply 360. Okay, so we get 360 times 16 pi, and I'm just going to multiply the 360 and the 16. And we get 5760 equals, what is it equal to? 2 pi r times 20. What's 2 times 20? 2 times 20. 2 times 20. 40. Pi r. Okay, the next thing is, my bad, I forgot this pi on this 5760. 360 times 16 is 5760. 360 times 16 is 5760, but I forgot to write down the pi. Moron. Okay, stupid. That was me. Okay, so now let's get r by itself. How do we get r by itself? Well, we have to ask ourselves, what is this 40 doing to the r? It's multiplying. What is the pi doing to the r? It's multiplying. What's the opposite of multiplying by a 40 and a r? Dividing by a 40 and a r. Shoot. What's the, my bad, I meant to say, what's the opposite of multiplying by a 40 and a pi? 40 and a pi. Dividing by 40 and a pi. There's too many symbols. I'm panicking. Okay. So we're getting r by itself, and I panicked. But we're supposed to divide by everything that's on the r, which is a 40 and a pi. Okay, on the right, the 40 cancels. The pi cancels. And all we're left with is a good old r. What happens on the left? Well, let's figure out what this 5760 divided by 40 is. 144. And then the pi's cancel. So, to get that r by itself, we divide it by the 40 and the pi. And when that happens, on the left, the pi's cancel out too. And we just have to divide the big fat numbers to get the radius of 144. Woo! Okay, last one. Yep, last one. Okay, it says find the length of a 40-degree arc of a circle whose radius is 7 centimeters. Okay, so they gave us 40 degrees, and they gave us radius is 7. Okay, well, let's go. Arc length. The formula from down here is arc length equals 2 pi r theta over 360. Okay, so let's plug in what we got. We got the r and we got the theta. The pi is a symbol in our calculator. Huzzah! Okay, arc length is what we're supposed to find. Darn. Okay, well, let's go for it. This is going to be 2 pi times the r and the theta over the 360. So 2 pi times the r of 7, the theta of 40, and then we're just going to multiply the numbers. Let's leave the pi as it is. So let me just multiply the 2, 7, and 40. $560. So we get $560 on top, and there's still a pi over 360. Okay, let's try and reduce. I think you can reduce by 10 for sure, but maybe you can divide by something bigger than 10. 20 for sure. Ooh, I can divide by 40. Okay, let's reduce. And you can either just divide by 2 over and over and over and over again, or I saw that I could reduce by 40, so I'm going to. Okay, if I divide the top by 40, I get 14 pi over on the bottom. If I divide by 40, you get 9. Yeah. So 14 pi over 9. Okay, let's try and put that into a decimal, just because in part B we're going to have to explain something about being bigger or smaller. Okay, so let's put this as an actual number because we don't really know what the heck pi is. Okay, so for pi, let's say 3.14. So 14 times 3.14 divided by 9. We're just finding this so that we can do part B. Okay, so 14 times 3.14 equals 9. Yeah, I got 4.9-ish. Okay. So the answer for part A is 14 pi over 9. But part B asks us to compare the size. And we don't really know what that is as a number without the pi. So we typed in 3.14 for the calculator, and we got 4.9. Okay. Part B says explain why the arc length in part A, 4.9, is longer or shorter in centimeters if the radius had been 11. Okay, so let's say the radius is 11 and we still have 40 degrees. Okay, well, let's do the math. We still have to find the arc length. So we're going to say 2 pi times the r and the theta over the 360. And the r is 11 and the theta is still 40. Okay, so let's figure out what this is. We could either reduce right now by 40s or at the end. I'm just going to go ahead and multiply all the big numbers up. I multiplied 2, 11, and 40. Whoa. Yeah, and I got 880 with a pi still up there, all over 360. And then let's reduce. You can reduce by 2 over and over and over again, or I can kind of see that we can divide it by 40. So let's do that. Okay, so 22 pi over 9. Okay, if I were to put that in the calculator so that I could see what the decimal was, it'd be 22 times 3.14 divided by 9. And I got 7.7-ish. Okay. So part B says, explain why the length in part A of 4.9 is longer or shorter than the length in part B of 7.7. Okay, so both of these circles are talking about a 40-degree angle. But the difference in that 40-degree angle is how long the radius is. So when I have a radius that's bigger, my arc length is bigger. It goes from 4.9 to 7.7. Yeah. So we can say the bigger the radius, the bigger the length. So as our radius gets bigger, if our angle is the same, our arc length gets bigger, because a radius of 11 would not be this tiny triangle, this tiny circle that I drew. A radius of 11 would be like almost twice as big. Yeah, this would be a circle of radius of 11. So the bigger radius we get, the bigger arc we get. Okay, part C says, find the arc length when the radius is increased to 11 centimeters. Okay, I think we already did that. That was what we did on part B. Yeah, we already did. So the arc length for part C is what we already did in part B, 22 pi over 9. So the whole point of that question was to show you that the bigger radius you get, the bigger answer you're supposed to get. So on your homework, your part B should be bigger than your part A if the radius is bigger. Okay, woohoo!